Yes, good evening guys to all of you. Please tell me, am I properly audible and visible to all of you or not? Yes. So as you know that we are going on with the probability. This is the qualifier series. First topic probability was going on and we have almost completed all the topics of the probability like Bayes theorem, conditional probability, all those things, independent event we have seen. And today we are going to start the random variables and statistics parts. This part will go on for 2 sessions, this session and one more session next week. And then we will be having a practice session on probability. With that, next weekend, we will complete the probability. After that, we will be starting the differential equation. Yes, Divya, aspirant. Good evening, guys. Jai Surya, good evening. So guys, as per my promise, I am providing you the practice sheets also. I am providing you handwritten notes also. I am providing you the PDFs of the session as well. And when we are talking about today's session is important because generally random variable is a topic where students are facing difficulty. Yes, good evening, Zakhmi Atma, Vinay, Nishant, good evening. So guys, we will be starting now the random variables. And guys, this topic is slightly mechanical civil students are feeling difficulty because this is more, you can say, core part of ECE peoples. But don't worry, I will try to make it that much easy for you that you will be able to understand about that. Pranali, yes, you can appear, but not with the computer science. You need to take some other paper, like either you will be appearing for mechanical or civil or ECE or EE. Because for ESE, only 4 branch paper is there. Yes, you can apply through any of those 4. Yes, Lakshmi, good evening. Papa Goda, good evening. Malesh, good evening. So we are starting now, guys. So guys, this is some detail about me, and you know mathematics is going on. This is my Telegram channel link, Mechanical by Dheeraj Sardana. You can join that to get the PDF of the session, to get the practice session, to get the handwritten notes, to get all the notifications of PSUs and all. So moving further, guys. There is an announcement like tomorrow, you know that 2nd October is there. So tomorrow, my dear, in the morning, 10 a.m., this video will be live where me and Abhinav sir have shown the live tour of BYJU'S exam prep office. Many times I have seen students are asking, sir, sometime when we are taking the classes from office, sir, how your office looks like. Many students visited also, they met us and we have shown the office to them. So guys, all those students who are interested to see our office, tomorrow this will be office tour, which will be by me and Abhinav sir. You can join there and we will show you each and everything related to the office. And for 2nd October, there is a gift for mechanical student also. Like guys, we will be having a marathon on complete vibration. You know, this topic is coming for 4 to 6 marks in GATE exam. So I will be dealing with theory as well as numerical. The timing of the session will be same 6 p.m. and we will go for at least 2 to 2.5 hours and we will be completing vibration from theory and numerical, both the aspects. We will not go for derivation although. Okay. Yes, Arun, good evening. So we are starting the session, guys, now without wasting the time. Are we all ready? Get set, go. So guys, if you remember, when I started probability for you, I defined something known as random experiment. Okay, just give me a minute. Let me check. Audio, video, everything is clear now. Just give me a minute. Yes. Fine, guys. Okay. So now we are starting, guys. And when we have started, I already told you something related to random experiment. What is a random experiment? For that, I have, this is for mechanical, for civil, for EC, for EE, all the branches. Mathematics is common. Random variable is there for civil as well. Okay. So my dear, when we are talking about the random experiment, this is something which will not be having a predictable outcome. Like if I am going to toss a coin, you know that either head can come or tail can come. But you cannot say with certainty that head will come all the times. So that is why, my dear, let us say I am going to toss a coin for 100 times. And all 100 times I am getting head. Then my dear, then also I cannot say that the next time head will come. So this is something we are not having the predictable outcome. So that is said to be a random experiment. Tomorrow's session for civil also it is useful because vibration, single degree of freedom system is also there in the civil engineering students. And if you are looking for XC paper, in XC also vibrations is there. So definitely it is useful for civil. But why I said that it is a gift for mechanical, because for vibration, for mechanical student it is for more weightage. That's why. Okay. So when we are talking about the random experiment, you can take one more example. Like you are having a dice. So when you are having a dice, you can see 1, 2, 3, 4, 5, 6. Any number can appear on the dice. No one can say with the 100% prediction that 2 will come or 3 will come or 4 will come if it is a fair dice. Okay, so that is what I want to say, my dear. That is what I want to say. There is no guarantee for that it will be coming. So random experiment is an experiment whose outcome cannot be predicted with certainty. So why I am telling you today? Because we are starting once again the random variable. So we require some basic definitions. So my dear, I already told you when we are tossing a coin, we are having two outcomes, head and tail. Both can come. So this thing is said to be sample space. Okay. Rolling a dice 1, 2, 3, 4, 5, 6. These are the possible outcomes. This is said to be sample space. And my dear, every element in the sample space, like you have 1, 2, 3, 4, 5, 6. They all are said to be sample points. So this 1, 2, 3, 4, 5, 6 are the sample points. Yes. Okay. Good evening, Anupav. Good evening. So let us move further. So guys, when we are talking about each element of sample space is called sample point. So this 1, 2, 3, 4, 5, 6, they all are said to be the sample points. And my dear, whenever we are talking about this, all things are said to be the outcomes. Outcomes together are shown in a bracket is said to be sample space. And my dear, these are also said to be the sample points. Now my dear, we are coming to a new definition because from here we are starting the random variable. So guys, we are going to talk about first of all what is a function, because random variable we will be defining with the help of the function. So my dear, let us say we are going to have two sets. Let us say we are going to have two sets. In this set I am having some number 1, 2, 3 like that. And in this I am having some number like this 1, 8, 27 like that. So this is set 1, this is set 2. So can you see, my dear, if I define a function y is equals to x square or y is equals to x cube, which out of them can map these two sets? If you are going to take the function x cube, you know that 1 ka cube is 1, 2 ka cube is 8, 3 ka cube is 27. So my dear, this is the function which is going to help us in mapping these two sets. So my dear, function performs the mapping between two sets under some predefined condition. Is it clear? So are you getting it? This is how we are defining a function. Now why I am defining this function? Because random variable is a function which perform the mapping between sample space and real line based on predefined condition. You may be saying, sir, ये तो लिखा हुआ है, समझ में नहीं आया. So I am showing you that. Let us say we are going to have toss of a coin which can have the possible outcomes as head and tail. When you are saying possible outcomes, this is your sample space. Yes, it is. And let us say when I am watching or I am looking for a cricket match, our captain Rohit Sharma is asking for head. So obviously we want head should come. So my dear, there are two possibilities. One, head can come. Second, tail can come. So when head will be coming, I will be saying 1. When tail will be coming, I will be saying 0 because we want head. So for that, I will say 1 means yes, we get 1 head, we get 0 head. So my dear, this is said to be the random variable. So my dear, this random variable, whenever we are talking about, this is a function. This is a function like we have defined. This is a function which performs the mapping between the sample space and the predefined condition or the real line. What is the real line? That we want a head. I am going to predict it in more better way. Like let us say we are going to have tossing of two coins. So my dear, what will be the sample space for tossing of two coins? We can get two tail. We can get one tail, one head. We can get head, tail, and we can get both the heads like that. So these are the possibility. And let us say, my dear, random variable, you are defining that you want head. You want head. So I am saying that we are going to say that we want head. That is we are going to define the random variable. We are going to say that we want head actually. So when you are saying this random variable, whenever you are talking about, if you are looking for head, can you tell me how many heads are there here? 0 heads are there. How many heads are there here? 1 head is there. How many heads are there here? 1 head is there. How many heads are there? 2 heads are there. So my dear, this is the random variable which is going to help us in mapping the two things. One thing is what we are looking for, we show it by lambda. Second thing is the sample space. So between the sample space and between the things we are looking for, wherever we are going to make a mapping between these two things, we are going to say that function which is helping us for that as random variable. So please tell me, everybody understood the random variable or not? So random variable is a function which helps us in mapping two things. One is sample space, other is real line. Sample space will be the all possible outcomes of that random experiment, and real line may be what you are looking for. Is it clear? Random variable, generally we are denoting it by x. Either you will denote it by x or you can also denote it as x lambda. Here lambda means what you are looking for, like I am looking for head. Then my dear, we are going to find out the probability, that also we will discuss, but slowly we will move on. Okay, one by one we will move on. I feel everybody is getting it. Thanks guys for understanding and replying. Okay, let's move further. So I feel Abhinav sir was also there in the comment section, I have just seen. Fine guys, so we are moving further guys. So we have already defined the random variable and we will be denoting it by either x or x lambda, where lambda will be the domain actually. Okay, so my dear, where lambda will be the domain actually. So my dear, we have already defined. Now let us see what kind of events we can form. We can form any number of events like that. Okay, like my dear, let us say we are going to toss, let us say three coins. Let us say 3 coins we are going to toss. Then what will be the sample space for that? If you see the sample space for that, you will be having 1 head, second head, third head. This is one. Second, we can have 2 heads, HHT. Then we have HTH. Then we can also have THH. Then we can also have, my dear, 2 tails. For that we will write TTH. We will write THT. We will write HTT. We can get all the tails. And let us say this time we are saying that we are looking for tail. So my dear, what would be the random variable? Lambda means we want tail. So for that, this time how you will be making? You will be saying this is 0 tail, 1 tail, 1 tail, 1 tail, 2 tail, 2 tail, 2 tail, 3 tail. And everybody know that if you are going to toss a coin, the possible outcomes are 2, and you are tossing 3 coins, so the possible outcomes will be 2 to the power 3. That's why you have written 8 sample points. Okay, and out of those, you know that how we have denoted them, lambda 1, lambda 2, like that. So there are 8 sample points, and this is how we are going to define the random variable. So please tell me guys, everybody understood how we are going to define the random variable? We will also see what are the various types of random variable. And guys, if you remember in the last class, we left 5 questions. So those 5 questions also we will do. So today we are going to see the basics of random variable. And then in the next session, we will be going for all the distributions one by one. Okay, I feel everybody is getting it. So guys, this is the way how we are going to make the events. Now my dear, let us see some examples. There are some questions I have made. 2 coins are tossed simultaneously. Number of tails represent the random variable. How you will be mapping? So 2 coins, you know that, head and tail. So 2 to the power 2 will be 4. So you will be writing the sample space. Now you need to map it. What is the sample space? You can have HH, you can have TH, you can have HT, you can have TT. So they are saying you need to map random variable is number of tails. Okay, so if you are talking about number of tails, it is 0, it is 1, it is 1, it is 2. So my dear, this is how we are going to map. Okay, and my dear, in the upcoming question we will also be finding out the probability. Like if someone asks you the probability of x more than equals to 0, or let us say make it some interesting, let us say more than 0. So if someone asks us find out the probability of more than 0, x more than 0 means what? X more than 0 means x is number of tails, means number of tails are more than 0. You are getting here 0, all other numbers are more than 0. So 1, 2, 3. So 3 divided by 4. Are you getting it? How we will be finding out the probability? Yes. Similarly, if someone say that find out probability x more than 1, then my dear, you would be saying the answer will be only one outcome is that is 1 by 4. So today we are going to see the basics of random variables only, and we will be making the base strong. You guys know that I always believe in the base, and if the base is strong, then in the upcoming classes you have seen the magic. Like first 3 sessions we went slowly with the basics, and then the last week session, you have seen wonderful questions we have done. So likewise we will be making the base of ours. Second is, a dice is rolled until 5 comes for the first time. If number of times dice rolled is considered as random variable, perform the mapping. Are we ready for that? So guys, if we are going to write the sample space for that. So my dear, when we are writing the sample space, you know, they are saying we are going to throw the dice, and we are doing it when we are getting the 5. Okay. So let us say you are getting 5 for the first time only. Second possibility, you are not getting 5 for the first time. So I am writing it 5 bar, because other than 5 we have 5 more number, 1, 2, 3, 4 and 6. So I can get any of them. Then second time I got 5. Then my dear, let us say I didn't get 5 for the first time, didn't get for the second time, but got for the third time. Then let us say I didn't get for the first time, didn't get for the second time, didn't get for the third time, and got fourth time. So likewise we can have many possibilities. So if I am going to define a random variable for that x, what is x? You can say that I need 5. So my dear, if I need 5, how will we will be writing? So my dear, actually he is asking the number of experiment. Okay, so I can write x number of experiment to get the 5. So my dear, this time I am getting 5 in the first time only. So I will be writing for this first. Here I am getting the 5 in the 2 times. So for that I will map with 2. So this is mapped with 1. This is mapped with 2. Here I am getting 5 in third time. So it is 3. Here I am getting 5 in fourth time. It is 4. And so on. Are you getting it or not, guys? Please tell me that. Yes, Malesh, Aspirant, Sagnik, Divya, Jaisurya, Papa Ka Ghoda. Yes, everybody. Please tell me, guys. Anupam, are we getting it? So I am going very slowly, guys, very slowly, so that we can learn each and everything from basic. Even if you have not done anything before, you will be able to understand. My target is to prepare you for everything. Great, guys. So then, my dear, this is something different. This time we have coins are tossed simultaneously. If number of tails plus 1 ka square is the random variable, calculate probability of x more than equals to 6. Okay. So my dear, 3 coins are tossed simultaneously. You know, if 3 coins are tossed, total outputs will be 2 to the power 3. It will be 8. So my dear, you will be writing the sample space. Sample space will be, you know, I can get 3 tails. I can get 2 tails. I can get 2 tails like that. I can get 2 tails like that. Then I can get 1 tail and 2 head. Like this. Like this. Like this. And we can also get all the 3 heads. Yes, we can get. So my dear, this is the sample space. Now look at it. The number of tails plus 1 ka square is the random variable. So So random variable is this time number of tails plus 1 ka square. So my dear, if you will see, how many tails are there? How many tails are there? How many tails are there? 3 tails are there. So 3 tails plus 1. 3 plus 1, 4 ka square is 16. How many tails? 2 tails. 2 plus 1, 3 ka square is 9. Then once again for here also 9. For here also 9. For here 1 plus 1 ka square is 4. Here also 4. Here also 4. And then here I will be having 1. Everybody got it? Because 0 plus 1 ka square is 1. Everybody getting? This is the mapping. This is the mapping. Very good. Sagnik. Sagnik, are you saying the probability? I am not asking the probability. I am asking first of all mapping. After that we will see probability as well. Because I am teaching like you are studying for the first time. Okay? We will go like that. So everybody do like the session यार. आपकी फैकल्टी स्पेशली 8 साल बाद मैथ्स पढ़ा रही है आपके बेनिफिट के लिए. Yes. So guys, this is going to be now we are going for probability. If he is asking what is the probability of getting x more than equals to 6. So my dear, if I want to find out the probability of x more than equals to 6, then my dear, how many times you can see that number is more than 6? Is this more than 6? No. 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 But these are more than 6. So my dear, 1, 2, 3, 4. So whatever probability answer you have given, that is correct only. I feel someone have given the answer. So my dear, what you will write it? You will write here 4 by 8. Answer will be 1 by 2. So this is how the question will be asked, guys. Is it clear? So I feel Sagnik have given the answer. That's correct. Clear for everyone, guys? Clear for everyone, guys? अच्छा लग रहा है, मजा आ रहा है, फीलिंग हो रही है random variable वाली. Okay, moving further, guys. Shall we move on? Fast तो नहीं हो रहा, बहुत आराम से चलेंगे, कोई जल्दी नहीं है, पूरा सीखना है. We are going to cover it completely. Next week probability खत्म होगा. Next week we have 2 sessions, one for practice, other for completing the variables. So guys, then now we are talking about there are 2 types of random variables. So my dear, there are 2 types of random variables. First is discrete random variables. Second is continuous random variables. So guys, like when we have seen the previous example, there you were saying, let us say previous example, you were saying the number of experiments. The first question we have done, the number of experiments in the dice case to get the 5. So those number of experiment will be either 1 or 2 or 3 or 4 or 5 or 6 or 7. Like that kind of finite values will be there. Okay? Or you can say the previous case. In the previous case, you are saying number of tails plus 1 ka square. It will always be integer, na? 2, 3, 4, 5, 6, 7, 8, 9, 10, 16. Like that number will be coming. Okay? So my dear, when this type of numbers are coming, we are calling the random variable to be discrete. But whenever the random variable is going to be defined in a range like 2 to 5, like that, then we call it as continuous random variable. And both the types of variables we are going to use, sometime we will be using discrete, sometime we will be using the continuous. For discrete random variable, we are generally defining the probability mass function. We are defining the probability mass function. Okay? And my dear, when we are defining probability mass function, here we are using the summation word. Because we are having discrete. Whenever we have discrete, generally we are using this summation part, and whenever we are talking about this range, here we are generally using the integration. And also I would like to say here we call it as probability density function. Here we call it as probability density function, which we will be using for calculation purpose. Okay? We will define one by one. Yes, very good, very good, very good. Aspirant, wonderful. So guys, this was the basic. Now my dear, whenever we are talking about the discrete random variables, I already told you some important points, that a random variable that can take the finite values, like I have given you some examples. Okay, and here we are going with probability mass function. So my dear, for a discrete random variable x, we define the probability mass function, and that is given like probability of A can be written as probability of x is equals to A. Okay, we are also having some properties for this, that also we will see one by one. So my dear, the first probability is, you can see the probability mass function PA is positive for all the values of x under consideration. So you can say that probability of xi is going to be always more than 0. So you can see it is going to be always more than 0, where I can be 1, 2, 3, anything. Okay, so it is always going to be more than 0. And whenever you are going to take the summation of probability mass function, you will be writing I is equals to 1 to n, and that is Pxi. Then my dear, you would be finding out the total sum will always be equals to 1. Okay, these are the properties I will be using while solving the numericals. Is it clear, guys? Everybody is getting? Don't worry, soon we are moving to the questions. Everybody is getting this? Then my dear, we are moving to the next property. Before we go for the next property, we are going to define something known as cumulative distribution function, that is CDF, for discrete random variable. My dear, we are going to define this as fx is equals to probability of x less than equals to x. Are we getting it? So my dear, we are defining the cumulative distribution function like this. What do you mean by that? It is going to be somewhere, you can say, like I am saying f of x. So if you are saying f of a, that is the cumulative probability function, means what? It is going to be the probability of all x less than equals to a. So the point is, you can also write it as 1 minus probability of x more than a. So my dear, this is how we are going to define it, and we are going to use it right now. Then you will get the proper feeling of that. But this FA is said to be the cumulative distribution function, that is CDF, for the discrete random variable. And my dear, I would like to say, whenever we are talking about this cumulative, you can see x less than equals to x, means we will be adding all the probabilities till x. Okay, or you can subtract the probability of more than a from 1. You will be getting the value of this cumulative distribution function, that is CDF. Is it clear? So guys, CDF is defined for both, for discrete also, random also, continuous also. Right now we have seen for discrete. Okay, don't worry. So guys, the cumulative distribution function CDF can be expressed in terms of, like I have already defined, in terms of this we can define it. Okay, so one by one we are moving ahead, guys. Now there are properties which I already told you also. Like whenever we are defining a cumulative distribution function, what is the property of that? If you will be finding out for minus infinity, the answer will be coming out to be 0. Because generally we are assuming the total area of the probability to be 1. Okay, so when we are going to consider that, I will also be telling you one more thing. Like let us say if you are going to make a curve like this. Let us say you are talking about, I am throwing a dice. So my dear, you know that whenever I am throwing a dice, to get the number 1, to get the number 2, to get the number 3, likewise to get the number 4, 5 and 6. You know that for all the numbers, we are going to have the probability is 1 by 6. Here also probability is 1 by 6. Here also probability is 1 by 6. Here also is 1 by 6. Here also is 1 by 6. Here also is 1 by 6. So like whenever you are going to make this type of diagram, are you getting it or not, guys? Are you getting it or not? कुछ answer नहीं आ रहा है. Are we getting it or not? थोड़ा सा this is the part where mechanical civil peoples have doubts, because this is majorly concerned with the ECEE peoples. Okay, so if any doubt, please ask me. Okay, guys. So my dear, whenever we are talking about this cumulative, as it is cumulative means it is the addition of addition of the probabilities. Like my dear, let us say you can see the probability of getting 1 is 1 by 6, of getting 2 is 1 by 6, of getting 3 is 1 by 6. So if someone will be asking that probability of getting a number more than 4, so obviously you will be adding these two. Yes or no? So when you will be adding, obviously probability is going to always an increasing function. So that's why it is mentioned that for minus infinity, when you will be finding out, it will be coming out to be 0. For plus infinity, when you will be finding out, it will be coming out to be 1. And my dear, f(x) is a non-decreasing function. It can be increasing like this, as it is increasing all the times. It can be increasing like that, and my dear, at the same time, it can become stagnant at some time, but it will never be a decreasing function. Okay, it will always be increasing because you are adding the probabilities, so obviously it is always going to be a positive function. Okay, very good guys. So moving further, so one more thing is that CDF is continuous from right hand side. So when you will be going for the limits, then my dear, fx at a will be equals to fx at a plus. But my dear, it may not be equals to fx at a minus. So my dear, from left hand side, limit may exist, limit may not exist, but it will always be continuous from right hand side. This is one more property from which the question can come. So both possibilities are there. We can have continuous from left hand side and right hand side both as well, and we can also have the continuity only from the right hand side. So these are the properties which we will be using throughout the questions. Okay. So my dear, whenever we are talking about the continuous random variable, as I already told you, it will be defined in the ranges like 1 to 4, 2 to 6, 7 to 8, like that. And whenever I am saying range, let us say I am saying it is from 1 to 4. Then my dear, from 1 to 4, we can have any value. It is 1.1, 1.2, 1.3, all the values will be covered. So that is the meaning of continuous random variable, because it is going to cover all the values. For discrete, it is going to take only the finite values. Okay, everybody is getting it. So as I already told you, there we were using the summation. Here we will be using the integration. Like I am saying minus infinity to plus infinity, fx dx. That total integration will be equals to 1. Like you were writing previously, that p xi I is equals to 1 to n is equals to 1. Previously you were writing in this way, now we will be writing in this way. Is it clear? So don't worry, I will be telling you in the questions that will be giving you better idea. So my dear, whenever we are talking about the probability density function, as I told you, for continuous random variable, we will be going for PDF, and for discrete random variable, we will be going for probability mass function. So I already told you, here we will be denoting it like this: minus infinity to plus infinity, fx dx is equals to 1. And my dear, whenever we are talking about that fxx, that cannot be an odd function, and if it is going to be even function, you can also write it as 2 times of 0 to infinity, and that is fx dx is equals to 1. Okay, so this is also the property of this variable. Don't worry, we are going to the question. I feel you will be getting better idea there. Okay, moving. So my dear, this I am going to tell you how we are going to perform the integration. Whenever you are going to have a probability in range, like from a less than x less than equals to b, so we will be going for integration from a plus to b plus. Why a plus? Because x is more than a and less than equals to b. That's why we will be going from a plus to b plus. If we are having a less than x less than b, then my dear, we will be going for a plus because it is more than a, and as it is not equals to b, so we will be here going up to only b minus. These things I will be using in the questions, I am telling you, but there you will get better understanding. Similarly, we can have a less than equals to x less than b. It is a minus to b minus. Why? Because my dear, here it is equals. So because of that equal, here we are having the minus sign, and here it is less than only, so we are not having the plus sign. So you can see, whenever you are going to have a less than x less than equals to b. So for more than function, if you don't have equals to sign, I will be starting from a plus. And here I have equal sign, that's why I will be going for b plus. Similarly, if I am going to have a is less than equals to x and that is less than equals to b, then my dear, I will be going from, as it is less than equals to, I will be starting from a minus. It is less than equals to, I will be going till b plus. So that is how we need to take the integration based on these limits given. Is it clear? So now I feel I must come to the questions, then only you will be getting properly. Okay. So everybody got till this point, whatever we have discussed, please tell me that. Then we are moving to some of the questions which will give you some idea. Then my dear, ECEE students are going to study something called as signal and system as a subject. There they study a impulse function, where they assume for an impulse function, like you will be having this x-axis, y-axis, and they are going to consider here that this is a line, vertical line, and my dear, this vertical line, here we are having x is equals to 0. So this line, obviously, if you see, there is no area covered by that. But we assume that there is a finite area covered by x is equals to 0, and that area we are going to define as minus infinity to plus infinity. But as we are making this curve at 0, so we will be taking from 0 minus to 0 plus delta x dx is equals to 1. This is said to be the impulse signal or impulse function. So we would be using this now in the questions. From there you will be getting the better idea. I know this part is slightly difficult for mechanical civil people, but I told you all the properties we are going to utilize one by one, and there you will be getting the better idea. Actually, this is the first question we are going to deal with. So you can see, my dear, they have mentioned that fxx is equals to 1 by 5 e to the power minus x by 5. And they are saying that x is going to be, okay, I feel the statement is incomplete. Let me write the statement properly. It is x is more than equals to 0. And they have also mentioned calculate for x more than 5. Will you try this, guys? As you already have seen the impulse signal, will you try this? Will you try this, guys? Will you try this? Can we say probability of x more than 5 is defined as from 5 to infinity? Jai Surya, it is not very important. If you see, very few questions are coming, but as I said, this is there in the syllabus, so we are covering, but it is not that important, and that is why mechanical civil peoples are running also from that. But don't worry, actually the questions are not coming from this exactly. Questions are coming from the statistics parts, which is having mean, median, mode. There are some formulas you need to remember. From that, major questions are coming. Okay. So my dear, try to solve this question. So we will be having integration from 5 to infinity of what? 1 by 5 e to the power minus x by 5. Okay. And this integration you need to find out actually. That will be your answer. That will be your answer. Because we are going for integrating minus infinity to plus infinity. But you know, they have mentioned that x is more than 5. So that is why we are going to integrate in this range. So you need to tell the answer for this. Tell me. Very good. Gajendra have answered it 1 by e. Sagnik have also answered it 1 by e. So when you will be solving it, the answer will be coming out to be 1 by e. Very good, guys. Very good. Very good, Papa Ghoda. Yes, Malesh, are you there or not? Vinay, are you there or not? Fine. So guys, moving to next question. Before that, I would like to tell you a rank up series is going to start, where we are going to solve approximately 500 questions, out of which 250 will be solved in the class, 250 will be given to you as homework. Okay, is it clear? Wonderful, Vinay, Malesh, very good. And guys, download the app if you have not done yet, because on the app also many sessions are going on right now. Tomorrow 6 p.m. we are having the vibrations marathon. Okay. And guys, this question also I am writing the statement is slightly not correct. Fx is k into 5x minus 2x square. Okay. And it is 0. So I am telling you the range. It is when 0 is less than equals to x less than equals to 2. And you need to find out probability of x more than 1. So this is the example of continuous random variable. So my dear, you know that this is from 0 to 2, this is defined, otherwise it is 0. So when you are going to integrate from 0 to infinity, you are going minus infinity to plus infinity when you are going to integrate the fx dx. So you know that it is 0 if x is not in this range. So obviously you can reduce it to 0 to 2. 0 to 2, that is k 5x minus 2x square. You know the total area is 1. This will give you the value of k. After getting the value of k, you know that they are asking you probability of x more than 1. So probability of x more than 1, that will be nothing but the integration of 1 to 2 k into 5x minus 2x square dx. So guys, just solve it first, find the value of k, put the value here, you will be getting the answer. This is how you will be doing. Don't worry, we have 2-3 questions on that. After that, we are starting the last class 5 questions. Okay. So this session is not going to be too long, as these are the basic things I need to teach you. In the next upcoming session, we are going to have all the distributions. Okay. So answer is, are we getting k as 3 by 4? Are we getting 3 by 4? K as 3 by 4? Dear, actually, that we are going to do because total probability is 1. Okay, if you are going to define like this, minus infinity to plus infinity. So whatever be the probability distribution curve will be there. The total probability is going to be 1. That's why we are going to integrate from minus infinity to plus infinity. But later on they are mentioning 0 to 2 this, otherwise 0. So we are going to break it 0 to 2 and otherwise. Got it? Yes. So this session, guys, I know is slightly boring type because the topic is like that. But still I try to explain you the things. So are we getting k as 3 by 4? Are we getting k as 3 by 4? Please tell me that. Yes, Malesh, Vinay, Aspirant, Sagnik, Gajendra, Jayasuriya. Okay, after getting this value, if you are going to put the value here, what is the answer of probability? X more than 1. Tell me, guys, tell me. Are we getting 17 by 28? Are we getting 17 by 28? Are we getting 17 by 28? Okay, 3 by 14 is coming or 3 by 4 is coming, guys? 3 by 4 is coming or 3 by 14 is coming? Please tell me that. 3 by 4 or 3 by 14? Tell me. 3 by 4 or 3 by 14? What is coming? Some are saying 3 by 4, some are saying 3 by... Okay, 3 by 14. Then put this 3 by 14 here and solve it. Are we getting 17 by 28? Because I have solved it. I don't remember the value. But the final answer is this. I have solved it. Okay. So the solution I have not written. So I remember the answer. 17 by 28 will be the answer. Wonderful, guys. 17 by 28 is the correct answer. Okay. That's correct. So this is some typing mistake. That's why for you I have written it separately. Next question is, once again, I am writing the question. Fx is lambda x minus 1, 2 minus x. And that is when 1 is less than equals to x, less than 2. And it is 0 else. And he is asking, okay, you need to find out the lambda value if it is valid PDF, valid probability distribution function. You know what we are going to do? Integration minus infinity to plus infinity. Fx dx is equals to 1. That will give you the value of lambda, and that you have to do. Try to solve it, guys. Try to solve it. We have 1 to 2 more questions after that. Try to solve it. We have 1 to 2 questions after that. I will be revising once also at the end. Don't worry, where you have doubt. And guys, next weekend session will be very important, because there we will see Poisson distribution, normal distribution, which you study in your technical subjects as well. Poisson distribution, normal distribution, binomial distribution, exponential distribution, all the distributions we will see. Tell me, yes. So Jai Surya, are you there? Divya, are you there? Murli, you got it? Solve it. Malesh, Vinay, aspirant, Sagnik. So Vinay is asking the answer to be 6. Very good, Vinay. The answer is 6. The answer is 6. The answer is 6. So you know minus infinity to plus infinity, but it is 0 other than 1 to 2. So we will be going for 1 to 2. X minus 1, 2 minus x, lambda dx is equals to 1. Very good, Malesh, aspirant. Answer is correct. Okay, guys. So today I am going to revise for 5 minutes what we have discussed. Then we will see the last time's question. Last time's 5 questions were pending with us. So I started first of all with the random experiment. You all know, if we don't know the outcomes with certainty, we call it as random experiment. Then function is something which is going to map the 2 sets. Okay. Then random variable is a function which is going to map 2 sets. Out of that, one is sample space and other is the real line, what we want to do. Okay. Then my dear, you can see the examples. Sample space for 2 times tossing a coin was this. X was the number of heads or number of tails. It will be like this. Then I told you it is denoted by X or X lambda. Then I have told you these mappings questions. And then after that, I told you there are 2 types of random variable. One is discrete, other is continuous. Discrete are those which are generally giving the values like 1, 2, 3, 4, 5, 6. These types of values which are finite values. And for a range values, we are using the continuous random variable. Then I also told you for discrete random variable how we define it. Okay, it is finite and I have defined it like this. And that also we have seen some properties. Here we use summation. Then also I have told you, like if you are going for defining the probability cumulative function, that is cumulative distribution function for probability, it is defined like that. We can also write it 1 minus this. And then we have also defined the properties where we told that this cumulative function of minus infinity is equals to 0, plus infinity is 1. Because plus infinity will cover the entire area, minus infinity will not cover anything. So that is why we have done it like that. I said it is always going to be increasing function. It will never be a decreasing function. Then my dear, I also have discussed about the CDF of continuous. It is continuous from right hand side. So limit will exist at right hand side, may or may not exist for left hand side. Okay. That also we have seen. Then I told about the continuous random variable, and then we have discussed about the PDFs, and also I have taken the properties like this fx will be lying between 0 to 1, the fx of infinity is 1, minus infinity is 0, similar to the previous one. Okay, then my dear, these are the range of the probability I told you. If it is written this, how you will be representing for the integration. Then we have discussed the questions directly. Okay, so my dear, now we are going to deal with some of the questions we were left in the last class. I'm going on to that. These variables we are going to see in the next class. This is the questions of last time. Last time we have not completed 5 questions. Up to 13 question we have done it. This was 14 question. Box 1 contains 3 red and 7 blue balls. We are having 3 red, 7 blue balls. And box 2 contains 6 red and 4 blue balls. 6 red and 4 blue balls. A dice is rolled if outcome is multiple of 3. A ball is drawn from box 1. Otherwise, the ball is drawn from box 2. What is the probability that ball drawn is red in color? What is the probability that ball drawn is red in color? Will you try this, guys? Will you try this? Will you try this? Please tell me. Let me share the session. I feel students are afraid of the topic. Tell me, guys. If outcome is multiple of 3, a ball is drawn from box 1, otherwise the ball is drawn from box 2. Tell me that, guys, tell me that. What will be the probability? Box 1, 3 red, 7 blue. And box 2, 6 red, 4 blue. A dice is rolled if outcome is multiple of 3. If outcome is multiple of 3, you know multiple of 3 is, if you say the total sample space 1, 2, 3, 4, 5, 6. The multiple of 6 are 3 and 6. Okay. So what is the probability of getting the multiple of 3? What is the probability of getting the multiple of 3? It is 2 by 6. Then, if it is coming the multiple of 3, a ball is drawn from box 1. Okay. If it is drawn from box 1, what is the probability of getting red ball? 3 by 10. This is the case when we get the multiple of 3. When we get the multiple of 3. Then, my dear, what is the second case? If we do not get the multiple of 3, it will be 4 by 6. And then it will be taken from this. What is the probability of getting red ball? 6 by 10. Yes. What is the answer we are getting? What is the answer we are getting? Have I done it correctly? 3 2 ja 6, 2 2 ja. And then we are going to have, is it 5 by 10, 1 by 2. Everybody got it? Papa Ka Ghoda have given the answer, Sagnik have given the answer, Malesh have given the answer. That's really great. Moving to question number 15. An insurance company insured 20,000 scooters drivers, 4,000 car and 6,000 truck drivers. The probability of an accident involving a scooter driver, car driver and truck driver is 0.01, 0.03, 0.15. They are not talking about कि इन्होंने accident कर दिया. They are talking about इनका accident हो गया. Okay. And then you can see one of the insured person meet with an accident. What is the probability that he is a scooter driver? Okay. That you need to find out. So my dear, first of all, you can see probability of scooter 2,000 or 20,000. 20,000, 4,000, 6,000. I feel it is a misprint. It should be 2,000. Yes, it is 2,000. So 2,000, 4,000, 6,000. Total is 12,000. So it is 2,000 by 12,000. The probability of car driver 4,000 by 12,000. The probability of truck driver 6,000 by 12,000. Okay. And my dear, they have also mentioned that probability of an accident involving a scooter driver as well as accident is 0.01. Is it clear? Probability of car driver meeting accident is 0.03. Then my dear, probability of truck driver meeting an accident is equals to 0.15. You need to find out the probability that accident happens and after that he found to be scooter driver. What will be that? That you need to find out. So it should be probability of scooter and accident divided by probability of accident. Can you try this? Can you try this? I have given you the idea. Probability of accident, after that it is found to be scooter. So you know that 2000 by 12,000 it is 1 by 6. So it will be 1 by 6. I am writing it in the form of sentences. This is scooter and accident, car and accident, truck and accident. Okay. So my dear, this is 1 by 6 into 0.01 divided by 1 by 6 into 0.01 plus 1 by 3 into 0.03 plus this type of question we have already done, 1 by 2 into 0.15. Can you tell me the answer, guys? Can you tell me the answer for this? Okay, Sagnik is saying 1 by 52. 1 by 52 in the calculator, what it will be? Okay, 0.0192. Okay. So are you getting 0.0192? Sagnik, Papa ka Ghoda, aspirant, all of you have given the same answer. That's correct. According to me also. Is it clear for everyone, guys? So guys, please tell me, are you feeling comfortable now? I know there are some things difficult with the random variable. If you find any difficulty, please tell me. In the next session, I will come up with more things for you. Okay, because I tried to explain. Yes, I know it is a revision crash course going on. So I am going in that way only. Okay. If you find difficulty, I can go more slow. Okay, that also. Fine. हाँ, अभी तो easy होंगे, पापा का घोड़ा धीरे धीरे बढ़ाएंगे level. Okay. Okay, next question is this. This question says computers are supplied to an institution according to the following information. Company X, company Y, company Z. 60%, 30%, 10%. Probability of getting defective are these. Then they are saying given that computer is defective, find the probability that it was supplied by company Y. So probability of defective by company Y. Solve it. I will everybody know for Y it is 0.3 into 0.02. Divided it. इतना आसान है यार. 0.6 into 0.01. Formula we have already discussed last time. 0.3 into 0.02. Plus 0.1 into 0.03. Solve it and get the answer. Don't worry. Question difficult भी आएंगे, easy भी आएंगे, हर तरह के आएंगे. Wonderful. So answer will be 0.4. Answer is 0.4. Bayes theorem. Yes. So I have discussed Bayes theorem last time. I already told you. Total probability, Bayes theorem. Second last question from my side. After that, one more question and I will leave you And don't worry guys, tomorrow we will be having a 2.5 or 2 hour session of vibrations. For mechanical and civil both it is useful. A laboratory blood test is 99% effective in detecting a certain disease when it is actually present. However, the test also yield a false positive results for 0.5% of healthy person tested. If 0.1% of population actually has disease, find probability that a person has disease given test results are positive. Solve it guys. This is the second last question for today. So we need to find out the probability of disease and test result positive. Once again the Bayes theorem. Okay. So you would be saying probability of D and T positive divided by probability of D. Solve it. This time I am not solving it, I am asking the answer from you guys. Similar hai, because last time we were unable to solve these Bayes theorem question. We solved for before that, but these 5 questions were left. Similar question it is. It is from NCERT actually, 12th class, because this question, these types of questions are coming in GATE directly from that. So tell me the answer in that case if that is that much easy question. 99% effective. Okay. So you would be having 0.1 into 0.1 divided by 100 into 99 by 100 divided by 0.1 by 100 plus yes. What would be the final answer, guys? Tell me. 100 you can cancel out. 0.4. I'm waiting for others to answer. Tell me guys, tell me. 0.16 is correct. Fine guys. The last question for today's class is, in a town 10% population is COVID positive. A new diagnostic kit arrived in the market. This kit correctly identifies corona positive individuals 95% of the time, corona negative individuals 89% of the time. A person is tested by this kit and found to be positive, then find the probability that person is actually positive. So guys, solve this. So you need to find out probability of actually positive. Okay. Kit is also telling positive. That you need to find out. Okay. So I feel it will be 10 by 100. The last question. Very good Vinay, very good Malesh. So guys, today was just the only introduction of random variables. Next class we will be completing them with good number of questions, good variety of questions. We will see all the types of functions we are using. For this, okay, Malesh is getting 0.4896. Vinay, what about you? What about you, Vinay? The answer for this. Tell me, tell me, tell me. Okay, guys. So let me solve here only. 10 into 95. I feel 0.489 is correct. Okay. So Malay's answer is correct. Goodbye guys for this particular session. We will be meeting now tomorrow 6 p.m. for vibrations. Tomorrow 6 p.m. for vibrations. Goodbye guys and thanks for your love and support. Goodbye, good night.